Sukanya.
Hi, so sorry. I just wanted to check if you want to share your slides and see if it's working.
Oh, yes, absolutely. Thank you. Can you see my screen in full screen?
Yeah, it looks perfect. Yes.
Let me test if you can see the slides rolling. You see it? You see next page?
Yes.
Perfect.
Yes.
Thank you. Then I'll stop sharing. So, Sukanya, is it okay that I say that Dr. Balakrishna Pisupati is present, but he cannot speak? I mean, I don't want to embarrass him. So, should I mention anything, or will this be done by Abhishek? You're muted again.
So sorry. I'm also new to this situation, so I'm also thinking what would be the best way forward. Maybe we can just skip them, and in the closing remark, one of the media official will take care of this.
You take the, okay, so I will not mention him.
Yeah, that works great. I'll just ask my colleague to take over for some time. I've been called in the office, so I'll just see you shortly.
So Evan, since we have actually a few more minutes, I see the panel maybe more interactive. I mean, of course, you can speak and make your points, but if you would like to react to someone else's points or to add something, that would be fine. I think we will have some time for exchanging some a little bit between the panel members.
Sounds great. And Raja, if it would be helpful, I do have one slide that I can have up in the background while I kind of go through my.
Perfect.
Great.
Hi, David. Nice to see you.
Hello, Mr. David. I request you to. Hello. We are not able to hear you actually.
Can you hear me now?
Yes, I
Yes.
can hear you now. That's great.
Okay. I was resetting a microphone in my
Oh.
system. Good to see you.
Okay. I request you to kindly change your name. It says speaker. If you could kindly mention your name, that would be great.
I think you're going to have to ask everybody to rename themselves because the link that you send out has this name contained within it.
Okay. Okay. Sure. Thank you.
By the way, Sukanya, I invited one of my colleagues in GPAI, Stefan Janus. I sent the link to him. So he's not speaking, but he's attending.
That's perfect. That's great. Thank you so much,
Thank
Professor.
you.
So Raja, what would it be helpful, what would be most helpful for me to cover given the sort of changing landscape of what people are talking about? I'm assuming you're going to be talking about the Project Arrays report.
Right.
So I don't need to cover anything there. I could talk about, sorry, please.
You can, David, given your fantastic knowledge, you can speak about anything you'd like to speak about. I will not have time to cover details about Ray's report. I have a couple,
Mhm.
4 slides or so, and I'm going to speak very globally on several things we've done. The first report, of course, and other reports as well, but never in details. So you're free to present any issues you would like
Sure.
to present. No problem at all. There won't be any intersection.
Okay, so if I presented a slide on the report, that would be okay. Are you going to present a slide like going into any of the recommendations, or are you going to just go at a really high level?
No. I'm going really to be very high level. So you can
Okay,
go
fantastic.
into the recommendations. Yeah.
I'll go into a few recommendations. Fantastic. Thank you.
Hi, good afternoon, good morning, depending on where you have joined in. Good to see you, Mr. Raja.
Good to see you too. Hello.
Yeah, and thank you for joining this. Really appreciate.
Thank you for the invitation and
Yeah.
for organizing this event.
Yes, I can see Mr. Paul also. Welcome for this convening. I'm just waiting for, we are almost, I think, 3 minutes away from the start.
Yes.
Very highly anticipated because especially India, we are really experiencing climate change and everybody's trying to see what all can be done. And I'm sure the projects with the expert committee and all have taken have a lot to offer with regard to the solutions we can have with regard to use of AI for coming up with some of these initiatives. We had it as a theme also in the AI Innovation Challenge that we launched a few weeks back. And we got around 60 very good solutions which have come through that challenge also on this issue.
Excellent. So you will mention this, I suppose, right?
Yeah. Sukanya, let me know when we should start.
Yes, sir. So, okay. Earlier your name was not featuring. It's working fine now. Thank you so much, sir. So we'll wait for a bit. I think few other speakers will be joining us, and then we can start.
Okay, okay. Attendees have also started joining. You have opened it up.
Yes, sir. Yes, participants have also started to join.
Okay. I think we can rename ourselves on the Zoom. Okay.
Jacques, do you hear me? Yes. Could you rename yourself on the Zoom? You are under speakers. So if you can put your name.
Yes.
Thank you.
Okay. Okay, I'm going to try to do it. Okay.
Leona, if you thank you for joining. If you can rename yourself, your name shows up as speakers. Good, that's it. Do we have everyone? I don't see Uri and Sarah.
I'm here.
Oh, you are here.
Sorry.
Okay,
I
Sarah.
just
You
joined.
can
Yeah.
also rename yourself, please.
I will rename myself.
अभिषेक क्या तुम बता रहे थे?
Kavita, you are not on mute.
एक मिनट.
Kavita, please mute yourself.
Hello, Sarah. How should I pronounce your last name, please?
Oh, the French way, dérubé. C'est bon?
Berube.
Dérubé.
Berube.
Il manque les accents en fait sur mes noms.
Oui,
Ouais.
d'accord. Merci.
Merci, Raja.
Uros is also.
Do you hear me, please, Abhishek?
Yes, I can hear you. I can hear you.
I
Thank you
could not
for
speak
joining.
for some reason. Thank you.
Thank you. Can you rename yourself? I think the link calls you speakers. If you can just rename yourself on Zoom.
That's strange.
Or maybe I will do it for you.
If you could, thank you.
And may I ask you how to pronounce your name, please, Juraj?
Yurai.
Chorba?
Yurai.
Jurai. And is it Chorba or Korba?
Yes, it is. It is. Yeah, yeah.
Chorba.
Uros has joined?
Yes, sir.
Then we have almost everyone. Let me text him. I think we should start because we are almost 5 minutes past. So to respect everybody's time.
Yes, sir.
Yeah. So thank you to all those who have joined here today for the GPAI virtual convening on climate change and AI that India is hosting as part of its being chair this year. And thank you for all the panelists and thank you for all the speakers who have joined in. So as we all know, AI has emerged as a transformative technology which offers innovative solutions to tackle some of the world's most pressing environmental challenges. AI is being used across sectors of healthcare, education, and all, but environmental challenges is somewhere what we have found, especially in India, that it's being is creating a huge impact on several dimensions. And it has, world over, it has been instrumental in advancing climate action by enabling better predictions of climate patterns, optimizing energy efficiency, supporting disaster management, and driving sustainable development practices. However, effectively leveraging AI for climate change requires robust collaboration, ethical governance, and addressing critical barriers such as availability of localized high-quality climate data, equitable access to AI tools, and the inclusion of diverse stakeholders in the decision-making processes. The other dimension of AI, especially with regard to climate, also remains that when we extend the usage of compute and start using high-end compute, the amount of energy that is consumed, that also becomes like a cause of concern. And always the question remains at what level we would kind of say that we no more energy for compute, and that can become the threshold level which will define the limits on artificial intelligence also. So AI can not only be used for solving such challenges, but AI itself can have a huge impact with regard to especially the energy usage for high-end compute infrastructure that we create. And we have been working globally with all our partners on this. In fact, the International Energy Association is also hosting a summit on AI and climate energy use in December first week. And at the GPAI summit also, we had several working groups present their findings. And GPAI also kind of presents the collaborative approach that is required for building coalitions, for building partnerships across countries, across communities, across stakeholders for taking up AI initiatives and projects for mitigating the climate change issue that we have. And GPAI unites the leading experts from science, industry, civil society, international organizations, and government to bridge the gap between AI theory and practice. Its efforts focuses on supporting cutting-edge research and implementing AI solutions that address global priorities. Under our leadership in the lead chair of GPAI in 2024 and December, we'll be handing over to Serbia as a chair and along with Slovakia. So several impactful initiatives we have taken during the year to advance this mission of leveraging AI for climate change. We did 6 convenings, virtual convenings on various thematic priorities of GPAI. We had the GPAI summit in December of last year, 2023 in Delhi, followed by the July summit wherein the integrated partnership with the OECD was approved. And all these summits, all these virtual convenings, all these discussions have primarily been focused to ensure collaboration and knowledge sharing amongst GPAI members and all key stakeholders. And this integrated partnership, which has been approved in July, and the first plenary that we had in Paris 2 weeks back, it helps us in bringing together the collective expertise of the 44 member nations along with the various experts to harmonize AI policies and research while ensuring inclusivity, especially by engaging developing and lesser developed countries. We are proud to host this virtual convening, which brings together a lot of expert speakers with whom we'll be speaking in a bit, and it will help us in defining the role in what ways we can leverage AI for addressing the issues related to climate change. As we prepare to hand over the presidency to Serbia, we are hopeful for future collaborations and we are confident that it will help us build up values and priorities that we have collectively advanced. So we have been like working with all the stakeholders for ensuring use of AI as a means for building solutions for addressing societal challenges at population scale. And India also outlined its strategy of AI for all in our national strategy on AI. And we also have defined our responsible AI approach document, which focuses on the OECD responsible AI principles, and it prioritizes inclusivity, transparency, security, and accountability in its AI initiatives. On the domestic front, we are implementing the India AI mission, which has an outlay of almost $1.3 billion, which focuses on building a robust and inclusive AI ecosystem through 7 pillars of building compute infrastructure to ensure access to compute, AI datasets platform, ensuring skilling for AI-related jobs, application development of use cases for in various sectors like healthcare, education, climate change, learning disabilities, education, governance. Then a means for startup financing, providing funding support to startups at all levels, building safe and trusted AI, and also building India's own foundational model. The application development pillar in particular focuses India's focus on leveraging AI for critical sectors, which include climate change and environment. As parts of our efforts to address the global challenges, we hosted a domestic convening on climate change and AI, which is as a precursor to this virtual event in which we have got the global experts from world over. The discussions highlighted the critical issues at this intersection of AI and climate action, including the challenges of data availability and accessibility. Themes such as grassroots engagement, fostering international collaboration, and leveraging high-quality localized datasets emerged as the key focus areas. Recognizing that these challenges resonate across similarly placed countries, the convening underscored opportunities for scalable and collaborative solutions. So this virtual convening builds up on the discussions we have had so far to foster a collaborative environment for addressing the challenges of climate change and we hope that we'll be able to identify through the interventions of experts and discussions that we have planned to identify actionable solutions that will enable GPAI member countries to harness AI's potential for meaningful climate action. And together we will be able to drive progress towards a more sustainable and equitable future. Today's agenda, as we all are aware of, will have Professor Raj Chatalia, the professor of AI at the Sorbonne University in Paris, and the co-lead of the working group on responsible AI. He will make a brief presentation on the GPAI project on RAISE. Then we have a keynote presentation by Dr. Balakrishna Pisupati, the country head of UNEP. Then Sarah from OECD will give inputs from the OECD side. Then we have my colleague Yurai Shorba, the chair of the OECD working group on IGO, and the incoming co-chair for GPAI. He will be giving his inputs. Then we will have Uros Poluga, the GPAI co-chair and the who are hosting the summit in Serbia on 3rd and 4th of December. He will be speaking, and then we have a thematic discussions in which we will be joined by Ms. Leona Isabel from UNESCO, Mr. Ivan Paul from Salesforce, Dr. Jacques from INRIA, and Dr. David from Mila. So we have and then we'll of course have the discussions with all the participants who have joined here today. and the member countries who are there, they will also get an opportunity to intervene. So we have a very packed agenda. So without taking any additional time, I will hand over to the session to Professor Raj Chatila, who is the co-lead, as I mentioned, of the Responsible AI Working Group and leading the project RAISE, for his presentation and moderation of this session. And truly grateful for Mr. Raj Chatila to have agreed to take over this responsibility. So welcome and thank you for doing this. So over to you, Professor Raj. Professor Raj.
Thank you very much, Abhishek, for the introduction and the presentation of the whole session, actually. For the sake of time, I will be very brief. I think we have today a fantastic lineup of speakers to speak and to address the multiple facets of the use of AI for climate action and at the same time mitigating the negative effects of AI. So I will start by trying to explain a little bit what we have done in GPAI Project RAISE, Responsible AI Strategy for the Environment, for the past few years. And before then passing the floor to other speakers. So I'm going to share with you a few slides about the project RAISE. Excuse me, put it in full screen mode. Yes. So I'm co-leading this project with Lee Tidrich from Duke University and Nico Mihaly from Prism AI. This project started very early on with GPAI. It was approved in 2020, and we started the work in 2021. It has several aspects. We worked on AI and climate action, climate change, and we issued a first report that was actually done with the help of David Rolnick here. He will speak more about this work and other things. We have issued also AI readiness guidance towards industry so that they can prepare for adopting AI in this context. And we have worked also directly with the OECD on a joint report about AI compute and it's the positive and negative aspects of AI as well. But since the beginning, we have seen also that biodiversity is a central issue for a responsible strategy for the environment, and that biodiversity and climate action are not separate. So we work also on another report about climate, about AI and biodiversity that had been published in 2022. And we have connected with several partners. The objective are to develop and implement a responsible AI adoption strategy. So this foundational report I mentioned was presented at COP26 in Glasgow. And we conducted this applied project about a few use cases that underlie the report recommendation. And we collaborated, as I mentioned, with the OECD. And this work has been presented in COP27 about compute. And we have also built a wide network of cooperation with various actors in the field. I will not mention them all, you can see them, for really leveraging our work and their work together. There is also a workshop that has been organized about a year ago. And this workshop have put together the whole RAISE community to discuss about the issues related to climate action and biodiversity at the same time, to bring together the initiatives and stakeholders, facilitate knowledge sharing and transfer. The one important point that has been raised is the inclusion of local communities. This is really key, specifically because of all the issues that are related to data sharing and data access, and also data ownership. And we try to find out a few best practices to find common grounds and move ahead on these issues. So some practical actions: explore open science and data protection methods for data sharing innovation. Measurements and metrics. This is a very important point. Actually, it's a key point to measure the impacts of the development and use of AI along the whole value chain. Otherwise, we will not be able to really understand what are the negative effects of AI, for example, to mitigate them, and how to develop a frugal AI systems. And with the progress in generative AI, it was also very important to evaluate the opportunities that are opened by generative AI and how this can be exploited with powerful AI systems. Now, in 2024, recently, we have participated in several events with the IEEE, which is the international organization. IEEE is the Institute for Electronic and Electrical Engineers, the largest technical society in the world. And we worked with them on in two webinars. One in June was about sustainability throughout the AI life cycle, and the second one very recently, actually a few days ago, about AI risks and opportunities for biodiversity. And you can see the lineup of the various speakers in these two workshops. We have issued also this guidance recently on AI toward net zero. And at COP26, the work that we have done on biodiversity was also presented and mentioned. Thank you very much. And I will stop sharing now. Thank you very much for your time. I will immediately move on to the next speaker. The next speaker is Mrs. Sarah Berube from the OECD. She is policy analyst in AI and emerging digital technologies division. Sarah?
Yeah, thank you so much, Raja, for this introduction of the important work that RAISE is doing. You have been leading on this file for the past years, and you already mentioned the report on measuring the environmental impact of AI compute, and I will show a couple of additional data as well, just to set the stage for this conversation. It is a true pleasure to be here with you today, and thank you to you, Abhishek, for extending the invite to the OECD for providing opening remarks to this very timely and important event. I just wanted to take the next 5 minutes to, as I mentioned, show you some data on AI in the environment that we have at the OECD. And let me just share my screen quickly. I'm not sure if I can actually. Oh, yes, I can. Okay. Because sometimes visualization can be worth 1,000 words. So I think that could help kind of seize the importance of this policy question when we're talking about AI in the environment. So as Raja mentioned, we have released a report in partnership with RAISE experts in 2022 on AI and the environment, because this was released in a context of increased policymakers' interest in the environmental impact of large AI models. And this report was launched at COP27, and the report aims to provide some framework by differentiating between direct and indirect environmental impacts. And the direct impacts are measured actually along the entire compute resources lifecycle, from production and transport to operations and end of life. And we're talking, for example, about mineral extraction, transportation, energy consumption, water usage to cool down data centers, and waste disposal. So this is the upper side of the slide that you see on the screen. And then when we look at indirect impact, we refer to positive and negative application impacts, such as beneficial sectoral applications in the electricity sector, for instance, and AI for climate mitigation and adaptation. And the report also notes that while we can get efficiency gains through technological progress, they might be offset by acceleration in resources consumption. And this is what we call a rebound effect. If I can show you actually what has been happening over the recent years, now that we understand a bit better what is the environmental impact of AI, you can see on the screen that the compute needs of AI systems have grown dramatically over the last decade, and the widespread introduction of generative AI tools has further increased the demand for resources, such as specialized hardware and software for training and deploying AI. The widespread adoption of generative AI tools across societies and economies, such as chatbot like ChatGPT, for instance, that everybody knows about, raises questions about the environmental footprint associated with the increased AI compute required to train and use large AI models, as well as wider systemic and mental impacts of AI applications coming from instance from AI inference. So as AI generative models become more widely used, policymakers need to accurately measure their compute intensity and environmental impacts. And this is actually data that is coming from our latest Digital Economy Outlook volume that was released last week. And it is quite striking, but let me give you some context around this chart. Up until 2022, the workloads of data centers have increased by several orders of magnitude, driven by, as I already mentioned, changes such as in AI advanced models. But their overall energy use has remained fairly stable. According to the International Energy Agency, so also called IEA, between 2014 and 2022, data centers' energy use represented 1% of global energy demand. However, recent changes in generative AI since 2022 may have changed this trend. The IEA estimates that data centers consume between 240 and 340 terawatt hours globally in 2022, and this is a notable increase from prior years. And it means that data centers globally consume more electricity than some OECD countries. And in terms of magnitudes, because the chart is, I guess, quite small on your screens, the lower end estimates for electricity consumed by data centers globally approximates the electricity consumed by Australia. And the IEA expects global electricity demand for data centers to increase significantly in the next decade, in some scenarios up to twice the current demand. However, such projections remain highly uncertain. They depend on the pace of deployment, rate of efficiency improvements, and other technological trends. So the big question is whether efficiency increases can keep up with rapid technological changes, such as advanced AI models. If you're interested in the topic, you can read the Fresh Off the Press Digital Economy Outlook, Volume 2. So Chapter 3 focuses on digital technologies and the environment, with a section on the energy consumption of data centers. So this is what I just presented. And I'm also adding the 2022 report that Raja mentioned on the environmental impact of AI compute and applications, since it provides a good framework to think about the issue. And one of the report's recommendations is actually the expansion of data collection on the environmental impact of AI compute and application. This is something that Raja raised in his presentation. So we're very much looking forward to hearing experts on climate data quality and access today in this webinar. So thank you so much, Raja, and to Abhishek as well for inviting us. And yeah, looking forward to the conversation.
Thank you. Thank you very much. I'm going to move now to Mr. GPAI Chorba, GPAI Co-Chair, is chair of the OECD Working Party on AI Governance, IGO. GPAI?
Thank you very much, Raja. Also, a big thank you to India and Abhishek for inviting us and me to be able to speak to you today. The topic we are discussing in this session can hardly be more important. I'm connecting to this session from Bratislava, Slovakia. In other words, from Central Europe. We've been experiencing over the past few months some severe floods, not only in Central Europe, in Germany, Poland, Czech Republic, Austria, and Slovakia, but also recently in Spain. I guess at least the Spanish news have hit the global news. So you are well aware of the possible implications of the warming Mediterranean Sea for conditions here in Europe and around the globe. At the same time, we need to remain focused and optimistic and constructive in order to face the challenges. And I would like to remind all the distinguished participants that when we discuss AI, we are actually discussing how we model reality. In other words, we are now discussing a new technique, how we actually create a new interface between our physical, real lives as humans on one hand, and everything that we call our environment, including the other life on planet. And the AI will hopefully give us a unique opportunity to model and analyze and predict our relation with our environment, our planet, including the climate. There is a huge opportunity for us to better take account of certain economic and non-economic values, to better analyze data that is available, and of course, as highlighted by India, the organizer of today's meeting, data access and structured data, high quality data, together with human capital, able to analyze and make benefit of these is, of course, absolutely crucial. It is also of no coincidence, perhaps, that we are discussing the potential impacts of artificial intelligence and its infrastructures on the climate change and the planet environment at a times when we have entered into a international agreement 2 years ago in Montreal, where in contrast to the artificial intelligence, as we call it, the Montreal Agreement provided for better keeping and recovery of what we call the natural environment. So here we are facing an interesting paradox in the history of humankind, where we at the same time try to create artificial intelligence, yet to keep our natural environments. We may need to think what this actually implies and what should be the lessons learned as we deal with these challenges. So with that, I would like to commend again the India's co-chair Abhishek and India as such for bringing us together to this important topic on this relevant time. And I, as co-chair of GPAI and Slovakia as such, will do our best, of course, to drive this issue further with Serbia, provided that we get confirmed as co-chair of Global Partnership on AI also for the next year, for 2025. So this is the message from Bratislava, Slovakia, and I'm very happy to be here with you today. Thank you very much.
Thank you, Joy. That's very important message. Let me move to Mr. Uros Poluga, who is the head of the team for implementation of AI in public sector in Serbia, and who is incoming co-chair for 2025 of GPAI. Uros?
Thank you, Raja, very much. Greetings to all participants and guests, and good evening, good day, good morning to everybody. I'm honored to have the opportunity to address to all participants here, to say that integration of countries and AI is moving forward. This promises to enable even better global answer to its challenges, several of them mentioned here. Climate change, of course, and the environment require everyone to be included. I'm glad to see that some of the world's finest experts on AI are working to offer recommendations and provide guidance to policymakers and offer solutions how to tackle this problem. From the Serbian side, we had a great experience with India as a GPAI leading chair. 2 ministerial summits and a beautiful Delhi helped us to understand the way GPAI works and to be able to take a very active part in its transformation that will result in the summit that is taking place in 9 days now in Belgrade. So I would like to stress that the summit preparations are finalizing and that we are very happy to welcome everyone who is available to come to Belgrade. On the sideline of this event, there will be a lot of panels, including the panel for agriculture, climate, and environment. We hope that this will contribute to the discussion on this topic. We will organize several booths for experts to promote their work, as well as a Q&A session where experts will be able to answer questions from the fellow experts, policymakers, and other participants at the summit. And we see this as a great opportunity to promote the ideas about how to tackle climate and environmental challenges. One of the ideas during our application for the co-chairing of the GPAI was to help in better promotion of this initiative through improved use of the GPAI projects. We believe that the RAISE is one of those projects that should be better promoted, known and implemented in as many countries as possible. We hope to help GPAI 2.0 move forward with developing those projects on this important matter. We hope to be able to, together with Slovakia and Uri here, help all projects fulfill their goals and that outputs are truly promoted and used in as many countries as possible. We hope to preserve experts' engagement and contribution and to help them cooperate to provide usable outputs. Serbia is also the agricultural country. We have a fair number of companies that deal with agriculture and climate challenges using AI. We hope to use the results of these projects and include our experts in collaboration. We are developing projects that should enable better use of energy, predictions on renewable energy resources, and predictive maintenance, all in favor of improvement of environmental conditions, energy efficiency, and contributions to climate preservation. We also hope to continue to work with all member countries and experts, and we will provide our efforts to enable more outputs, more dissemination, and more use of those outputs, so to say. So one more time, I would like to thank India for organizing this session and for guiding the GPAI through some difficult times into the GPAI 2.0. And also, I would like one more time to welcome everyone to Belgrade, to the GPAI Summit, and we expect help, support, and collaboration for this joint cause, and to do 2025 to be an improvement and for better cooperation. So thank you very much one more time.
Professor, you're on mute. Sorry.
I'm so sorry. Yes, thank you very much, Uros. Let me now move to another session now, which is a panel in which we will address several technical, practical approaches to deal with the issues of climate action. So it's my great pleasure to welcome the four following speakers. Mrs. Leona Verdadero from UNESCO. She's Program Specialist, Digital Policies and Digital Transformation at UNESCO. Mr. Evan Paul is Senior Director, Innovation for Nature at Salesforce. Dr. Jacques-Marie Sainte-Marie, Head of ICT and Environment Program from INRIA in France. And Dr. David Rolnick, Assistant Professor at McGill University and core member and Canada CIFAR AI Chair at MILA in Montreal. So as you can see, we have speakers from international organization, from industry, and from academia to address these issues. And I will introduce first Mrs. Verdadero. Please, Leona, the floor is yours.
Yes, thank you so much. I'm just checking if my audio is working well. Good morning, good afternoon, good evening. Very thrilled to be part of this panel. Thank you for inviting me. So I just have 3 brief slides, but essentially as an introduction. So yes, thank you with the intro on my profile. So I am a program specialist at UNESCO. I work at the Digital Policies and Digital Transformation team, where we work on evidence-based policy guidance and capacity building for our 194 member states. And here I am thrilled to present a publication preview called Greening the Planet or Growing the Footprint. Can generative AI be made sustainable? So this publication was made in partnership with the University College London Computer Science Department. And this study addresses the pressing question that many of our earlier speakers have really mentioned. So at the intersection of AI innovation and climate action, how can we harness the potential of generative AI while minimizing its environmental cost? And so if we move on to the second slide, please. So essentially with this publication, we have three main objectives that I'm happy to discuss today. So the first is with respect to demystifying the energy footprint of large language models with respect to the inference phase, followed by doing a deep dive into energy efficient AI strategies, and concluding with what does it mean to develop recommendations for sustainable or green AI. And so with the first objective, with respect to demystifying the energy footprint of LLM inference. So, as we know that Gen AI is rapidly becoming a part of our daily life, and whether we realize it or not, but from virtual assistants answering our questions to AI-generated content helping businesses automate tasks. So we are increasingly becoming dependent on these technologies. And at the heart of Gen AI are large language models, so systems that generate human-like text, provide answers, translate languages, and create content. So these models, as we know, are the foundation of many of these Gen AI tools that we use every day. So it makes it very crucial for us to understand the energy consumption involved in running them. And so, if we narrow down the scope to the inference phase, so inference refers to the process where a trained AI model generates answers, predictions, or output based on a user's input. And here, we are making a strong case. So why does inference matter, right? So inference is how AI models come to life for everyday users. So it's really the process of the AI system answering your queries and interactive with the users. And unlike the training phase that many of us are maybe familiar about, right? So training phase in large language models, it happens once. However, inference happens every single time the AI is used. And so this continuous operation really makes it the main driver of energy consumption over time. And for emerging economies, so inference is critical because it's tied directly to deployment and accessibility. So if inference becomes too energy intensive or too infrastructure heavy, so it really creates a barrier for emerging economies, developing regions to adopt AI equitably. And so for instance, so in terms of specific data, so what we are seeing that, in the inference phase for a query in a large scale language model, it can consume between 0.3 to 2 kilowatt hours of energy, which is equivalent to approximately, 15 to 60 hours of charging a smartphone, depending on the battery size, also equivalent to running a small sized refrigerator for about 2 to 5 hours. So based on this, just imagine that at scale, on average daily, for instance, ChatGPT processes at least 10 million queries, and we're expecting this to even grow more, exponentially. So we can see that the energy demand rapidly escalates. And also we're seeing that the inference accounts for over 70% of the total energy footprint of large language models in their life cycle, making it a critical area for intervention. And so for low resource settings, so inference really poses a unique challenge as infrastructure constraints and energy costs make continuous operations unsustainable over time, right? And so with respect to, and then for us, really the challenge was doing a deep dive, right? Moving into objective 2, deep dive into energy efficient AI strategies. So the second focus of our study is really finding concrete ways to reduce the environmental impact of AI systems while ensuring that, they remain accessible, especially in regions with limited resources. So the first experiment is really done with respect to how to make models smarter, not bigger. So here it's really demystifying that, the bigger is better paradigm, because what we're seeing is that to make AI more energy efficient, we can focus on improving the models themselves. So they need less energy to run, right? So instead of making AI models bigger, why not make them smarter and more efficient? So one very practical and concrete way to do this is through an optimization technique called quantization. And so, what is quantization? So in a less technical term, you can think of it as compressing a file into a zip folder, right? So you're sending an email to a colleague at a very large file size, and you can compress it using a zip file to be able to send it, your email, to your colleague. So here, what quantization does is instead of adding more data to a model, so the quantization is a technique that will compress the model. So making a large language model smaller, but still preserving its ability to perform. So here, we really looked at it in terms of the energy efficiency and accuracy metrics. And what we have found is, through our experiments, so, having different size models doing comparable tasks relating to question and answer, translation, sentence generation, we're finding that by applying quantization techniques, reducing the size of the model and the complexity of calculation, quantization can actually lower energy consumption by 22 to 44%. And so this makes AI models more suitable for resource-constrained environments, while also keeping the same performance. And so here, despite with respect to the performance, because it's also a key criteria, of course, for many users. So despite reducing the precision, quantized models can actually retain near original task accuracy for many applications. So here we're finding a balance between efficiency and performance. So this is one, optimization strategy, quantization that we are looking at, and the study reflects a lot of these key findings. And then the second strategy that we tested is looking at smaller, more task-specific models. So here, instead of using, a large general purpose model for everything, we looked at smaller models that are focused on specific tasks, right? So on like agriculture or climate monitoring. And then we're also seeing that, these smaller models, they use less energy while being just as effective for their intended tasks. And they can actually make AI more affordable and accessible, especially in areas with fewer resources. So with respect to some key findings, so for the task-specific models, so compared to general purpose models, when we did some task-specific fine-tuning, so it led to 15 to 50 times lower in energy consumption. And so here that, we're really seeing that smaller models can be more energy efficient for certain tasks, and you don't need a giant large-scale model for every application. And lastly, with our final objective, so concluding with developing, evidence-based recommendation for sustainable AI. So in the study, we've had, recommendations that are targeted to 3 groups. So the first is with policymakers. Second is actually for the tech developers and the users. And third is for the general user, many of us who interact, with an AI model, perhaps on a daily or near daily basis. So with respect to some of the recommendations that we feature, and a lot of this is also a call to action and a call for collaboration. And as you know, with UNESCO, we also collaborate, with many of the stakeholders here on different areas. And here we are growing our work with respect to building sustainable and green AI. And so some really of our policy recommendations focus on adopting green AI standards. And we know that many of the colleagues here are part of that. And so it is also our intention that by, presenting this evidence-based research, some of these key findings could support the standard setting process by this evidence that we are generating. So it's really, adopting green AI standards. How do we establish, regulatory frameworks that can incentivize energy efficient AI practices, particularly in regions with fragile energy systems? And then also there's a recommendation on looking at open source low energy models. So here really supporting the development and dissemination of open source AI models that can be optimized for low energy environments. And also there's a collaboration for AI sustainability. And, we have also participated at the last COP and partnering with ITU on, green digital action initiatives. And there's also a lot of work being done on green computing, as well as with colleagues here with GPAI and OECD. And, you mentioned a report that was published on green computing. So on this front, we're very much happy to collaborate. And then with respect to recommendations for tech for the users themselves, so there's really a very, very strong call for first, promoting transparency and the energy efficiency of AI models. And so here we support initiatives that are being led by tech companies such as Hugging Face, so where, they have recently released an energy star ratings system, which you can see on their platform. So based on different open source models that they host and different, and most commonly used tasks, you can actually see the energy consumption of these different models. And we think that's really a great move in the right direction. So being transparent with the energy consumption and, being able to offer AI developers and deployers with the choice that given a set of AI models on different types of tasks, right? How would their choices be informed, right, with seeing this type of data? Could we nudge the industry to have a more eco-conscious mindset in the type of models that they would use and deploy? And then finally, with respect to recommendation for the everyday average user, it's really raising awareness and advocacy on the growing environment footprint of these large language models, and what does it mean to use that in a more eco-conscious and sustainable way. And so thank you very much. I wrap up my presentation here, but also just to, again, share that this report will be launched in early January, and we look forward to sharing it more broadly once we have officially published and released in January. So thank you so much. And my contact details are at the end, because I'm happy to stay in touch, and also call to action for anybody who wants to work with us on this space. So please reach out. Thank you.
Thank you so much, Leona. This is really a very important topic, the use of generative AI and its footprint. So we're looking forward to the report, and thank you again. Let me now invite Mr. Evan Paul from Salesforce.
There we are. Can you all see my screen? All right.
Yes.
Great. Hi, everyone. Thank you so much for the invitation to participate. This is a critical conversation at a critical time. AI, as you all know, holds both massive promise and, if we don't do things the right way, massive peril. And we cannot be talking about it and investigating it enough. I'll start. I'm on the nature team at Salesforce. So I'm within our sustainability group, and we have a dedicated team focusing on nature and biodiversity as an emerging topic for us and our customers. We see climate and nature as inextricably interconnected for reasons that are on the screen here. How that's getting operationalized is rapidly evolving. For us, we've had longstanding emissions targets to reduce our absolute emissions, power data centers with renewables, et cetera. We've also now recently been adding to that water commitments to ensure that we are not siting data centers in water-stressed areas and undertaking other efforts to mitigate our water impacts as our most material impact on nature. A critical part of all this work is our work on AI sustainability. We have a multi-part strategy around this. The top is, how do we minimize the environmental impact of AI? Again, to maximize the potential positive use cases while minimizing harm. There's three parts to this. One are right-sizing models, and I'll show you some a quick example of that work in a bit. Using as efficient hardware as we can, so that anytime we're using data centers, it's on the most efficient hardware we can get our hands on. And then siting data centers in low carbon regions, areas that have renewables on the grid. There's increasing conversations about nuclear. Microsoft is investing in a major nuclear plant in Pennsylvania, for example. And we think that, yeah, siting in low carbon regions is going to be another key pillar of this. On the right sizing models piece, and Leona mentioned this previously, we've been finding the same thing, that not every large language model needs to both write code and write poetry, right? You can actually design a model to do specific tasks, and it's not only better and hallucinates less and has greater accuracy, it also dramatically reduces the energy footprint and potential carbon emissions. This is just from our own training. We had dramatically improved performance compared to our peers at Google, Meta, and OpenAI. Again, we are not training models to do all things. We are training them for very specific purposes related to sales, customer service, marketing, things that we support. We also think the AI for good part of this is crucial. These are two legs that we need to continually be advancing the state of art of applying AI for good as well as mitigating the harms. We run an AI for Impact accelerator where we give funding, expertise, and technology to nonprofits around the world to leverage AI to scale up and improve the efficiency and effectiveness of their work. One I just want to point out from our recent AI for Impact Accelerator was Climate Collective. They're based in India. They do fantastic work, and they are leveraging Salesforce AI in their work to find ecopreneurs, so entrepreneurs with sustainability focus throughout the global south and connect them to investors, help them develop their businesses, et cetera. They do fantastic work, and they're going to be leveraging Salesforce AI to do so. The final piece that I'll just mention here is that this is only going to get more complex and impressive. The emerging wave that we're seeing at Salesforce and Microsoft and many others is agentic AI. These are autonomous models that can make a plan, make decisions, and take action, and essentially take on a role, a job role that a human would play. This is no longer science fiction. This is getting launched. We've already launched some agents on some customer service use cases that are acting independently with a human in the loop, but taking independent action to field customer support requests, resolve those customer issues directly. And you're seeing some really incredible also sustainability use cases. So for example, we're working with the state, with a nonprofit, or actually no, they're a social enterprise, Producers Trust, and the state of Andhra Pradesh to design agricultural extension agents that can work with human agricultural extension agents to engage smallholder farmers through WhatsApp and voice to help those farmers adopt regenerative agriculture practices. So imagine a workforce that is 24/7, 365, and then can meet someone out in the field when they get connectivity to help them learn about regenerative agriculture, how to qualify for carbon credits and other benefits from it. The ability to scale up our reach, engagement, and then change is really unprecedented if we leverage agents in the right way. So very promising technology. Also, massive potential energy user if not designed right and following some of the principles that I mentioned earlier. If you'd like to know more about what we're doing on responsible AI, here's a recent blog post from July. Please check it out. There are a number of other white papers, et cetera, that we've recently written, and be happy to field questions.
Thank you very much. That's really a very important point as well. I mean, the move to agentic AI will multiply indeed these systems in a way that is difficult to predict, and therefore there are also climate impact. Let's move immediately to the next speaker, Dr. Jacques Sainte-Marie from INRIA, head of the ICT and Environment Program.
Thank you. Yeah. Thank you very much. I'm very happy to be here and to share with you a few ideas. Few ideas I have as a researcher, as a mathematician. I'm also a mathematician at Sorbonne University, but also as a member of the board of INRIA, that is the National Research Institute for Computer Science in France. And I have no slide, but 3 ideas to share with you. Some of them has already been expressed and detailed by especially the first speaker of this panel. My 3 ideas are the following. First, we need artificial intelligence to know, to model climate change and to have some accurate forecastings. The second idea, or once again, it has been already said, that we need to move to specific AI model. I don't think that the history is made with very generalistic tools for AI, but for any of the objects we have produced in the humankind. And the third part will be about the AI, the footprint, the carbon footprint of AI, and the way perhaps to change it or to motivate people to work on frugal AI. So my first point is that we need AI to model the climate change, the environment, the ocean dynamics, the natural hazard. Why? Because during decades, our knowledge has been based on mechanical, physical model, biological model that were some laws that were able to know, to parameterize and to simulate with computers. But we are not at the end of the story, but we have to face some very complex problems. We have huge set of equations with a very large number of parameters, and it's difficult to make progress in the way to simulate, to approximate this mechanical model. And AI is definitely a tool that allows us to make strong progress in the way to explain, but also to have forecasting, to have evolution of climate and of weather. Typically, this is a great challenge for us in the sense that we have to build new architecture. I mean that we have to build model where our system coupling this mechanical model that remains an important ingredient of the modeling, but also with the data. And we have to find a way to, I would say, hybridize this knowledge based on data and this knowledge based on mechanical model. And we have to do this. It's not enough to say that temperature will rise of 3 degrees at the end of the century. We have to know some very accurate impact of climate change for agriculture, for mobility, for land use planning, I don't know, but at the very small scale for in each country. My second point is about the need to develop specific AI model. And my first sentence will be how, typically if you ask to ChatGPT or whatever, the recipe of an apple pie, some poems of Victor Hugo, of Shakespeare, of an Indian writer, it will answer you. And it will be perhaps a good answer. It is no sense. It is no sense that some million of nodes of ChatGPT are dedicated to know some poems of Shakespeare or Victor Hugo. What is important is to know where it is located on the website, where to find them, but it's no sense to remember this. So my feeling, once again, is that we have to move to specific, dedicated AI system. It has been already explained by the first panelist, so I don't want to add more comment on that, but just to say that it has several advantages to have specific AI model. The first, of course, is scientific. It's easier to evaluate and to build such a system. But it has also an advantage over the economical aspect, in the sense that with this small model that can be elaborated and developed by a lot of actors, you favor innovation in favor of environment. And of course, and this specific model allow you to some extent to reduce the carbon footprint of your system. My third point, as I have told you, was about the carbon footprint of AI. First, I just want to give you two percentage. If you consider agriculture in France, but in most of the country, it's something like 20% or even more. 20% of the carbon footprint in France, but in other countries, is coming from agriculture. The impact of ICT, so AI is part of ICT, but the impact of ICT is something like 2.5% in France, somewhere it is 3 or a little bit more, and it's growing, clearly it's growing, but 3% compared to 20%. And when I say 2.5 or 3% as the carbon footprint of ICT, it's for whole ICT. If you consider the carbon footprint only of ICT for agriculture, it's few percent of this 2.5%. So perhaps 1.1 or 0.2%. So we have to compare 0.1% or 0.2% to 20% at the carbon footprint of agriculture. So my feeling is that clearly we do not have to increase a lot the carbon footprint of agriculture. But as mentioned by Sarah Berube, it is very important to take into account the indirect impact of ICT and especially of AI. If we allow a small increase in the impact of ICT, but with a strong impact of some of the activity sector that are responsible for a large part of our carbon footprint, of course, we win. We win in this case. We win a lot. My third point, my last point, sorry, is about the way to measure performance in some sense. It has been mentioned also by the first speaker of this panelist, and I want to give the point of view of a mathematician, of a researcher. Well, when I belong when I'm in scientific conference, when I see the program given by program chair of scientific conference, my feeling is that the award are given to people that are produce very big result with big infrastructures, with big models. So we have to define perhaps a new cycle of conference. We have to define new metrics, perhaps of course for industry, but also for scientists, for researchers to develop more frugal techniques, especially based on AI. Well, thank you very much. It has been a pleasure for me to discuss this, and I will be happy to answer the question, if any. Thank you.
Thank you, Jacques. Actually, for the several speakers that have already presented, there is a Q&A and a few questions that are addressed to you. You could have a look. We'll get back to that, but you could have a look already on this Q&A. Let me move now to Dr. David Rolnick. Great pleasure to have you here today, David. And the floor is yours to explain about your work in climate action. As a reminder, David is at McGill University and core member of Canada's CIFAR AI Chair at Mila.
Thank you so much for the introduction. It's a pleasure to be here. I'm going to give a really rapid overview of some of the things that we've been working on at Climate Change AI in facilitating the overall space of climate change and AI over the past few years. So as we've heard from many speakers, AI is a key part of many different strategies for climate action. However, impact is held back often by gaps in expertise, education, coordination, and infrastructure that have often meant that the potential of AI has not been fully realized, or that the way in which AI is being developed is not aligned with climate impact. And at Climate Change AI, which is one of my hats, in addition to my professor hat, we're a global nonprofit that catalyzes impactful work at the intersection of climate change and AI and facilitates the field of climate change and AI for the past 5 years. So we do that through an overall approach of democratization, leveling the playing field of AI and climate change and AI overall within this context, and coordination between often disparate stakeholder groups by empowering a global community of innovators, practitioners, and decision makers in the research and deployment spaces. And the overall facets of our work have to do with expertise and thought leadership, education and capacity building, building community and collaboration between different communities, and facilitating the research to deployment pipeline. And so I want to talk quickly about our work in these different spaces, but particularly focusing on thinking about framing the space, because I think that that's very relevant to a lot of the conversations which we're having today. With regard to really zoomed out, how is AI, how are machine learning and AI related to climate action? There's been a lot of discussion on these aspects. We looked at this a number of years ago to try to taxonomize the different approaches where AI is being used to facilitate climate action. And this text that we presented has been very useful in a number of different contexts. I want to quickly highlight some ways that you can think about the overall space of AI and climate action here, you can think of themes of distilling raw data into actionable information, optimizing complicated, so for example, that could be taking remote sensing data and pinpointing where flooding is happening, pinpointing the amount of carbon stored in forests, monitoring biodiversity, monitoring agriculture, optimizing complicated systems. So taking, for example, factories and making them run more efficiently, forecasting, like predicting the amount of energy used or needed in electrical grids, and accelerating scientific modeling and discovery. For example, in speeding up climate models or in models in materials science. I want to mostly focus, though, on some of our work thinking about recommendations for shaping the space of AI and climate change. First, in our work with Project RAISE and GPAI, providing recommendations for governments in how to facilitate the space of AI in a climate-relevant context. We looked at many different aspects of this, improving standards for data sharing and interoperability between different data sources, making those sources available for AI innovation. This is a clear gap that exists in many aspects of the AI and climate space, ensuring that there's funding not just for AI innovation in the blue sky sense, but also impact-driven funding. Developing cross-sectoral innovation centers where different parts of different communities can come together to facilitate collaboration in a very impact-driven way. Building capacity and literacy for AI in climate-relevant industries and the public sector, while also the inverse, building deployment-relevant capacity within the AI community as well, via upskilling and secondment programs. Establishing best practices for participatory design to ensure that this is done in a community-driven way, and, as I'll get to in a moment, considering positive and negative climate impact when shaping AI technologies overall. So what I want to dive into here is thinking about those different positive and negative impacts, which we've looked at pretty extensively and tie in nicely with some of what the other panelists have talked about. So in our report here, we tried to establish a framework for understanding AI's positive and negative relationships to climate action. And I want to talk about some of those, which have been, again, touched on by previous panelists. So I think this is nicely complementary. People talk extensively about the energy usage of AI and also the embodied emissions from hardware. And I think these are really important factors that have taken off in relevance as we've seen the growth in generative AI. These factors are actually small for most AI algorithms, but increasingly generative AI is very popular. And so they become extremely relevant to the world at large. But it's important to remember that those are just the tip of the iceberg. AI is arguably having an even bigger impact from a negative perspective on climate change through application-related impacts, like leading to as much as $500 billion in additional profit for the oil and gas industry through facilitating extraction and exploration, through changing behavior patterns in online advertising systems that are designed to increase consumption in some cases, fast fashion especially being strongly enabled by AI-based advertising, and through applications that really depend upon how AI is developed and used. For example, autonomous vehicles that can be used to make the climate crisis better or worse, depending upon whether they're used to increase personal driving via self-driving personal vehicles or autonomous public transportation and other options. The same technology can be used in many different ways. And so I want to highlight 3 different takeaways here. First of all, actually, the vast majority of positive applications of AI in climate change do not use generative AI at all, and they do not consume significant energy. So when people talk about a trade-off between positive and negative aspects of AI, this is actually not true, because mostly the AI that's helping climate change is not the AI that's using a lot of energy. And that's because these are task-specific algorithms. And people use task-specific in lots of different ways. Task-specific algorithms can mean task-specific generative AI, but this is not generative AI at all. Like, one doesn't use ChatGPT to identify trees in a satellite image. One doesn't use ChatGPT to optimize a factory. It actually doesn't work to do those things. And generative AI is the wrong tool for the job. It's not just overkill, it's actually bad. When you use it, it doesn't work. So you need other AI algorithms in those contexts. So there are definitely contexts where we need generative AI, but we can have positive applications for society and for the climate crisis without the ubiquity of generative AI. So I encourage everyone to look at things through that lens, because oftentimes AI is used as this catch-all term, but it means many different things. I want to touch now quickly on some of our other initiatives at Climate Change AI. We're working on many different education and capacity building initiatives. Here, our summer school drew 10,000 participants from over 150 different countries last year. Our events bring together different stakeholder communities at some of the world's largest AI conferences, NeurIPS, ICML, ICLAIR. Our next one will be at NeurIPS in Vancouver with a free live stream online. You can also check out the peer-reviewed papers that have been released in all of our different events there on our website. And we also bring together different communities through offering resources like our newsletter, providing updates on the overall climate change and AI space, and through community platforms for engaging across different stakeholder communities. We also try to facilitate work in this space through initiatives like our Innovation Grants Program, which has distributed over $3 million to innovative projects using AI to help tackle climate change around the world from many different countries and in many different areas. Thank you very much for listening, and I look forward to any discussion.
Thank you so much, David. So we have really examined many issues here, and I suppose there are several questions. Before moving to the Q&A, I will not raise a debate among the panel members because for the sake of time, we're already late. But before moving to the Q&A, I would like to ask if any member countries of GPAI, OECD, is online and would like to have a word or address question to the speakers. Hearing none. Okay. Then I suggest we move to the Q&A from the attendees in this case. So there is a special Q&A panel on the Zoom, but also maybe some attendees would like to ask questions orally, and in this case, they could just raise their hands and ask the question. So let me see if anyone. I see several hands. Antonios Stasis, can you? I don't know if the attendees can speak up. Please go ahead. Maybe you are muted, or yeah, I think your mic is off. We can't hear you very much. I'm going to ask the next hand. Yes, Ravi.
Yeah, can you hear me?
Yes, we can hear you. Go ahead.
Yeah, thank you so much. I mean, I was really looking forward to this webinar. I'm based out of New York. I work on food technology and really wanted to know, as you know, that the food sector contributes to about 30% of greenhouse gas emissions. So is there any specific example or initiative that is looking at working with the food sector on AI to make it more sustainable? I recently launched my own book. It's called AI for Food Movement in the food sector, of course. But we've been really grappling with this challenge and an opportunity to use the AI to make the food sector more sustainable. Thank you.
Thank you. I'm going to take a few questions before giving the floor to the panel members or whoever wants to answer. So that was about the food industry. Next, so Antonios, is your still not Alekia?
Yeah, good afternoon to you. Good evening to everyone. This is Alekia calling from Delhi, India. So we just wanted to have one question to all any of the speakers or the panelists there. So if we talk about AI, and of course, a lot of processings and those things are taking place. So what would be, kind of a mitigation strategies? Like, we have a lot of data centers and coming up, and in India we cross the peak demand in the summer, more than 250 gigawatt and all. So how to attain this kind of the newer loads that coming into the system, and because ultimately this will also have a larger impact if we again emit the carbon emissions for production of electricity instead of new things. How in the best practices are in the developing worlds people are attending these issues. Thank you.
Thank you. Next, there are 4 raised hands, so please take the mic and go ahead.
Hello. Hello. Hi.
Yes.
This is Chandan here from Vassar Labs. We are into climate tech company. We are AI powered climate tech company, and we deal in water management, agri management, and city management. The only thing that wonders me is like all of us, we are dealing in some part of dealing with the climate tech solution with AI, but we are working in silos, and unless and until there is a clear mandate from the government or organizations working together for this cause, we can't achieve this, noble goal. So, so I would like to understand, like, what is the government, what are your approach, and how the government is dealing in this direction? What is the laws that are being framed towards this direction?
Thank you. I can take this one just immediately. Actually, what we are doing right now proves that we are not really working in silos, because it's the whole community in the domain and governments who are involved in GPAI OECD to share their experience and to share their capacities to on these issues. So and this is an open, I would say, community. So you can join, I believe. Next question is Camila.
Yes, sir. Thank you so much. So my question is regarding the presentations of Salesforce regarding AI for Impact Accelerator. And I want to know if Salesforce has developed some kind of this initiative of AI for Impact Accelerator, like What Times or Google 360 in South American countries. So I want to know more about practical cases, especially in South America. Thank you.
Thank you. There are 2 more questions. I think Corinne and no, Shadan, you already asked the question. Corinne.
Hello. This is actually less of a question. My name is Corinne White. I'm the representative from the United States. I apologize for my late intervention.
Welcome.
But just wanted to thank the chair for hosting this informative session on such a timely and important topic. We're impressed with the experts' vital work so far, and we're looking forward to continued work going forward. AI has emerged as a significant new climate issue because it poses significant risk and benefits for progress in climate, and the increase in energy demand to support the development and use of digital technologies, particularly AI, raises serious concerns for the clean energy transition. At the same time, AI is being deployed to accelerate climate action globally, including for enhanced climate modeling and forecasting, disaster risk reduction, climate smart agriculture, and energy system management. So just wanted to say that the United States supports work to address these challenges and opportunities, including through capacity building for developing country governments. And we look forward to working as a part of GPAI 2.0 as we continue to search for practical solutions. Thank you.
Thank you. Actually, thank you very much for being with us today and for your words. Surupam.
Yeah, hi. So this is Surupam here. I work with Aether, which is a decentralized compute organization. So I had a question primarily related to the economics of and the feasibility of training AI models. What are the issues that primarily being faced while working on to training models into climate data changes as well as?
Surupam, you have been muted, or you are muted. We don't hear you anymore.
Yeah, so am I audible now?
Yes.
Yeah, would love to know the challenges that been faced which you are facing economically while training a particular model in AI for climate change. What are the economic challenges in terms of compute that is being faced while you utilizing traditional systems?
Okay. Economic challenges for AI systems. Shandan, do you have a question, or is it an old hand?
Sorry, it was the old hand. Thanks
Oh,
for
thank you.
the answer. Thank you.
Renu? Renu? Okay. Ravi?
Audible?
Yeah, I have
Renu,
one
go
more.
ahead. Sorry, Ravi.
Yeah,
Renu, go
thank
ahead.
you. Greetings to all. I'm Renu Sirotia. I am from a LawNet Partners, a law firm from Bangalore, India. I work at the intersection of technology, sustainability, and law. And my question is concerned to that. Am wondering whether there is potential possibility of convergence on disclosures of sustainability standards pertaining to the AI work of any kind of organization. Because as of now, in our jurisdiction, it is not AI specific. Only a few organizations are mandated to disclose about sustainability practices, but it may be from any sector. However, about AI, because AI has a specific carbon footprints and other climate related implications. So I'm wondering if there is discussion and if potential convergence amongst the jurisdiction is possible.
Thank you very much. We have a lot of questions. I hope the speakers have taken some notes because they are going to react to this. There are still two, no, Surupam, I suppose it's an old hand, right? And so I don't see any other hands. Let's address those questions. It's a wide range of questions about food industry, about the corporations, and about how we. There is a specific question to Ivan actually about Salesforce, the economic model, and also the how we can work on tech law from tech law and sustainability practices. So I see Leona is the first to have raised. Please, Leona.
Yes, thank you so much for giving me the floor again. But also, I'd like to address also a question from the chat, which asks specifically about the quantization experiment that we did as an optimization technique. So if you will, and because of the nature of this question, if you will all allow me to get a bit more technical, happy to do so. And again, please feel free to reach out to me via email, and happy to chat further and, discuss more of the technical details behind our experiments. And also just to say, we've done this all methodology with respect to, leveraging open source models and techniques. And so it's also the idea that we're sharing knowledge and the methodology as well. So with respect to the experiment, so just to preface that here we use the, in terms of the LLM, we use the Llama 3.18 billion parameters instruct, so available on Hugging Face, so as an open source model. So here we ran experiments related to language translation, text summarization, and question answering. So based on this, think about Llama 8 billion parameter model as the base model. And then from there, we applied several quantization techniques. And these methodologies are also open source, available online on Hugging Face platform, for instance. But essentially, we looked at 3 different quantization methods. To be more technical, they're called bits and bytes quantization. Another is general post-training quantization. And the third is activation-aware weight quantization. But essentially, the 3 are kind of different methodologies, but with a similar objective of applying, different types of compression techniques to make the model smaller, but still keeping the more or less the same levels of accuracy. So, think of it as we use the base model, applied quantization techniques in 3 different ways. And then from there, we also use, with respect to measuring the energy consumption, we used Code Carbon, another open source tool that would measure the energy consumption of each of the different models during the inference phase. So along those 3 tasks, with Q&A, text summarization, and machine translation. And then here in the study, we've published our results with respect to, if you can imagine, how it looks between a base model, Llama 8 billion parameters, applying different quantization techniques, how they were compressed, and then what is the level of accuracy, pre and post quantization. And yes, and I'm happy for this question. And again, this is all a sneak peek. And in January, the full publication and methodology will be available to all. Thank you.
Thank you, Ilona. David.
Great, thanks. Wonderful questions. I'll address 2 of them. First of all, agriculture. How is AI being used in sustainable agriculture? 3 main ways. 1, precision agriculture. That is using AI to help guide specific, often hardware-based solutions, like in tandem with robotics or sensor systems, to improve yield or use less chemicals. Those can both deliver sustainability benefits while improving agricultural outcomes. They are generally targeted for large-scale industrial farming operations. To date, most precision agriculture is not focused on smallholder agriculture, which is a major limitation. Second, remote sensing for enforcement of agricultural policies and sustainability commitments, like, for example, tracking deforestation in palm oil plantations, or as it relates to livestock farming. Those are 2 of the major drivers of deforestation worldwide. AI is being used in satellite imagery-based enforcement systems, for example, by the Brazilian Space Agency. Third major area is an adaptation to climate change, tracking crop production, again, using remote sensing to scalably understand where agricultural interventions need to be taken. This is initiatives done by, for example, NASA Harvest, the European Space Agency's World Cereal Program, both of which my group actually partners with. So those are 3 main areas where AI is being used, to my knowledge, in sustainable agriculture. I want to touch on 1 additional question, which had to do with what kinds of impact assessment are going on. And I also want to appreciate the US intervention by calling out a proposed, though not passed, US bill on the AI Environmental Impacts Act. This was proposed early in 2024, and looking at that bill, ideally passing that bill in the US, but looking at that bill could serve as a framework for understanding how one might go into framing the kinds of factors which are needed in setting AI standards moving forward. And again, there are various reports which several of us on the panel have worked on in this context as well. Thank you.
Thank you very much, David. For the sake of time, I see we are almost, we started late, so I'm taking a few more minutes. Jacques and Ivan can address some of the questions, but there is one that has come up. It's a really important question about how to use AI to address climate vulnerable populations issues, how to address super polluters such as methane, and also the problem of water. So maybe Jacques and Ivan, while you will answer the other questions, you can address these 2 points, and then we will have to wrap up. Thank you. Thank you very much.
Thank you. Yes, 2 questions I want to try to answer. The first, food, and the second, climate services. About food, it's really important, food. Why? If you want to have strong evolution over agriculture, that is a subject that has been mentioned by several people, the most easiest way is to have an evolution in the food, several other aspects related to food. First, if you suffer from a disease, well, you have a lot of publication, scientific publication that are giving you, I would say, information about what is possible for you to hit or not. But sometimes, if you want to have an accurate, a personalized diet, it's important to use this, to use AI, to use this kind of tools, and especially to develop some apps over your phone, for example, giving you daily what you have eaten the previous day, what is possible for you. And so it's very important, and AI can help this. Once again, to make an evolution over agriculture, and second, for your own, I would say, comfort with respect to the disease you can suffer from. And second aspect, second answers I want to give about climate services. I have said during my first introduction that it was important to develop a model for climate change, to some extent, prediction. And it's important to have accurate, I have mentioned, accurate prediction. And this is exactly this. This is the impact of this prediction over the economy, over all the human activities, typically in agriculture, but also in tourism. So it's very important not to stay at the level that it will be 3 more degrees at the end of the century. It's not completely useful for the economical decision every actor has to take in the future. We need some very accurate prediction.
Absolutely. Thank you, Jacques. Evan, you have the last words for the panel.
Well, I'll be very brief, and I'll leave it to you, Raja, to say something profound at the end. So I'll just address 2 quick questions. One was about, have we done any work with Latin American organizations for our AI accelerator? Yes, Global Forest Generation is doing amazing work with Acción Andina for large-scale restoration in the Andes Mountains, and they've been leveraging our technology to help manage and coordinate all that. Another question that was asked about the water aspect of AI, and I'll just briefly mention one of the efforts that we're making with partners is large-scale watershed restoration to mitigate in water-stressed regions, mitigate the impact of data centers because of generative AI, to try to just improve, increase the pie, and enable a greater water resilience, manage flood risk, and increase freshwater supply that can enable multiple uses, including data centers, if we increase the availability.
Thank you, Evan. Unfortunately, we cannot address all the complex issue of climate action just in 1.5 hours. So I have to stop now this part, and thank very much our speakers as well as the persons attending who asked very important and interesting question. Sorry, we cannot take everything. I'll hand the floor back to Srimati Kavita Bhatia to close. Thank you very much to India to have organized this convening, because we have really a very important issue to address here. Kavita, please, the floor is yours, and thank you very much for attending, everyone.
Thank you. Good morning, good afternoon, and good evening to everyone. As we conclude today's enlightening session, I would like to express my heartfelt gratitude to all the esteemed speakers, panelists, and participants for them actively contributing for this discussion. I would also like to thank our distinguished speaker and moderator, Professor Raj Chatila, for inspiring address and setting the context, as well as emphasizing the critical role AI plays in addressing the climate change, and also skillfully steering the entire session so that we have a meaningful deliberations. I am deeply grateful to Ms. Sarah Baruba and from OECD, and Yurai Korba from AI as well as the co-chair of our GPAI, and Mr. Euros Polgua from Serbia, who is co-chair for GPAI for 2025, for their valuable inputs and the perspectives they have shared in order to for us to understand how international cooperation and governance frameworks can address the responsible AI practices. I would also like to thank our distinguished panelists, Ms. Leona Isabel Verdera and Ivan Paul, Dr. Saint Marie and Dr. Stolnak, for their expertise and thoughtful insights into the challenges and opportunities the data quality and accessibility brings in this topic of discussion today. In fact, I would also like to express my gratitude and appreciation to Dr. Pashupati, who's joined us today, though being unwell and not able to speak, but I will really appreciate his presence and I wish him a speedy recovery. Additionally, I would also like to thank our audience who have been engaged with us and have given us their insights and how we can have a fruitful discussion. Now India is going to hand over the presidency to Serbia, and I'm confident that they will continue to uphold and bring upon the values and priorities that we have collectively advanced. We have no doubt that Serbia's leadership will bring fresh perspective and the renewed GPAI mission of promoting responsible AI development as well as deployment. On behalf of Ministry of Electronics and IT, Government of India, I would like to thank everyone once again for their active participation and support. Together, let us continue the work towards a sustainable, inclusive, and innovative future. Thank you all for being having a participative and a good discussion. Thanks a lot. Thank you.
Thank you.